Well, welcome back to the webcast. We're getting into summer here, about midway into the meteorological summer, and you can see we're under southeasterly flow, and what we have now is very typical for this time of the year here in Texas. Most of the precipitation we have is up to the north, and let me bring that up over Iowa. And yeah, I missed the outside cam. Let me take a look at that. I'll show you what it looks like from outside here, and very pretty right there. The sea breeze did try to sneak up on this area, but we're under a relatively inactive weather pattern here. So back we go to Iowa, and we've got a frontal system that's been pushing southeast through the northern plains, and we can see that cold air mass in the Dakotas and Minnesota, and the front has pretty much stalled out in Iowa and Nebraska. It's under ridging right now. So we're waiting for the next big kick to drive it southward, and there's those storms there just south of Des Moines, and my geography of Minnesota is not that great. I want to say that's Bethany, Missouri, out to St. Joseph, maybe just north of there. And so we've definitely got some sort of boundary through here, something like that. Back behind it, this looks like the main drive of cold air coming south. Tropical air mass definitely out ahead of that in this area here. And we also look for the dry line, and in this case, the dry line is very far west, way back there near Garden City, out to about Colby. And let's see, we've got a little bit of a thermal low, and the lowest pressures I see right around Lamar and Garden City, way down here in the southwest. This is due to the very intense heating in that area, and you can see pressures there about 1001 millibars, and that's about the same as what we have in those tropical cyclones off the coast of Mexico. Okay, we do have GR level 2 also, so we'll bring that up, and we've got one tornado watch out for far eastern Iowa. And admittedly, this would show up better on the Davenport radar, and I might just switch over to that. But there's that cluster of storms down around Bethany, and those look multicellular at this time. These warnings, let's see here, we've got wind gusts and $half sized hail. Okay, so we'll go ahead and switch over to the Davenport radar since it's very close to that tornado warned storm. And we'll be able to take a very close look at that. The tornado warning, that is for a confirmed tornado near Oxford Junction around 8 p.m. there. So just northeast of Oxford Junction, where that is. And we're just waiting for the radar data to come up at this time. So let me take a quick look here at chat. Andrew saying good evening. Rick McAllister from San Antonio, USAA. Yep, that's where my cousin works there. Fun with Tech is here. 40 tornado warnings today so far. 15 of them verified: Missouri, Iowa, Wisconsin, and now Illinois. Ryan is got a heat index there in Florida, 102. Typical steamy summer weather pattern. And Rick McAllister asking about the NWA conference. Ryan, let's see here, mentioning the big wildfires in Arizona and California. Okay, so we'll bring the polar orbiter data to the west and take a look at that too. And scrolling down here, Mr. Manlet, new viewer. Welcome to the program. Big shelf cloud over Rockford, Illinois right now. Lots of CG bolts. The Arizona fire, 39,000 acres. Geez, what's the, let me see. I'm trying to figure out what the square root of that is. Square root of 39,000. I guess it's about 100 to maybe 150. I'm trying to get an idea of square miles. I guess it's going to be right around maybe 10 to 15, maybe about 10 square miles there. Just a rough guess. Carl Berghoff joining. Weak tornado in northwest Wisconsin late this afternoon, about 60 miles away. Arakiel, happy Thursday from the UK. And I've kind of lost my place here. I see Michael Burrell, 13 in there. Brett Dean, another beautiful evening in southern Jersey, 71. Left a message on Facebook. Okay, I'll have to get back on there and look for that. New tornado warning just southeast of Rockford, Illinois. Justin Pulliam, howdy, lots of activity today. Yeah, so things are definitely active with that cold front moving through the northern plains. Okay, so at this time, I don't really see anything here indicating a tornado. Maybe, yeah, maybe this right here. I think that's what we're looking at. A little bit, maybe, of a weak hook echo signature there. I'm sure it probably looked a lot better earlier. Yeah, we run that back. Yeah, there's our tornado warning storm showing up much better. So we'll switch over to velocity, and we've got a lot of... We're going to have to factor in the storm motion, so let me do that. Try to get a little bit more green in here and a little less red. This is not the optimal viewing angle for that storm, so this is going to be kind of tough. Yeah, I think we might have gotten that kind of in the ballpark there. Okay, so at the time that we're looking at this, I don't see anything that looks like a very strong rotational signature in here. Maybe a little bit of one right in this area here. That could be an old meso or old cyclone rotated around to the backside of the storm. And then moving forward, this is more characteristic of what we have along kind of an outflowish boundary. Okay, so it looks like toward the end right there, we're starting to see a little bit more convergence and rotation start to come together right in this area here. So max inbounds right in this area here, that's going to be about 22 knots. And then max outbound in this area here, that's going to be about 25. So that's going to be about 50 to 55 knots of broad scale rotation right there. So the center of the meso looks like it's right in that area, and you can kind of see where that is in relation to the storm. So the supercell kind of embedded in all this stuff kind of like this. And then the updraft area looks like it's filled in with a little bit of precipitation, so we can't really call this a rain-free base. It's actually called a rain-free base, but sometimes that's not very accurate. But that's where it is, and that represents the updraft base. Any other tornado warning storms? Not at this time. Just cells going all the way back to Rockford and Milwaukee. Oh yeah, there's another tornado warning right there near Rockford. And I think one of the viewers mentioned that. So let me switch over to Joliet. I think maybe... I guess maybe the Milwaukee radar is a little bit closer, but that's going to be cutting through a lot of precip. So I'm going to go ahead and stick with Joliet for now, and there's the warning. Tornado and quarter-size rotation, radar indicated, and that's near Belvedere, moving east at 40 miles an hour. And Belvedere, that's where the old American Weather Observer publication used to be printed. And yeah, that storm definitely looks pretty imposing. Updraft area pretty much right there. We've got the hook kind of swinging around the southwest part of the storm right there, and you can see that the meso, we're pretty much going to find it right in this spot. and that should track right down the center line of that warning. Wow, that last frame looks even more strong. Yeah, look at this. We've got 70 knots inbound, 30 knots outbound. That's about 100 knots of broad scale rotation. We've got, let's see, a little couplet here of, let's see, 57, maybe about 60 knots of rotation right here. And then probably some other really strong shear right here. This is going to be about maybe 30 knots, not quite so strong. But it's mostly the large-scale signature. That's, yeah, let me see here. 43 versus 20, that's going to be about 63 knots of shear right there. Let's see what that is. Yeah, that's probably the tornado right there where that dot is. And let's see, we got a new frame come in, and we'll just check that out real quickly before we move on. Most of the stronger inbounds are held way back to the west, so again, kind of a large rotation signature, but we're starting to see probably a little bit of wrap up of that hook echo with that last frame. So you see there's kind of like a donut shape there. And as we go higher up in the storm, well, we've got older frames, but you you can see the overhang right here. So you see these higher reflectivities. And we'll take a quick look at a cross-section of that storm from northwest to southeast. And there's that overhang area right. Well, actually, this is the overhang, but this is the rain-free base area right underneath. So a lot of precip, and especially wet hailstones being suspended aloft by a very strong updraft. And you can really see some of that updraft here. Tops up to about 45, 50,000. And down below it, not much there. So this is all air on its way up. Okay, let's see here. I guess we'll start down the charts and satellite data, since there's weather going on elsewhere. Looks like a fire danger there in Utah and Arizona, and we've got that wildfire out there, so we'll take a look at that. I'm going to try to use the polar orbiter for that one. Yeah, what happened to my polar orbiter page? There it is. Okay, yeah, let me move this back. The stream may degrade just a little bit, but let's see. I think this is the fire we were looking at earlier north of Phoenix. And then there was another big one going on in Utah yesterday. I don't see quite as much smoke out of that one, so looks like they may have contained that a little bit. I haven't looked at the news on that, so... All right, here in Texas, we're underneath southerly flow. You can see the southerly gradient. We've got the Gulf pretty much open, and southeast winds coming right there out of southeast Texas up to western Oklahoma. So you can see if we add the 850 millibar analysis in, we can see a little bit of that low-level jet energy working its way northward. You can see those 30-knot winds underneath here, a little bit of 35. And if we change the sector over to the Midwest, we can take a look at the dew point field. And we can see there's quite a bit of moisture all the way from central Kansas all the way over to eastern Illinois. But again, this time of year, theta E's are very important. So here I've plotted theta E, and the highest values are found in northeastern Kansas. Very high values along the Interstate 70 corridor. Why is this area not filled with thunderstorms? Well, I've got a good suspicion, and I'll show you why here very shortly. But further out to the east, theta E is a little bit lower. And remember, we've got to look at the area out ahead of the storm. We don't want to be looking at this data back here because that's all outflow air. We're very interested in this tropical air that represents the inflow into these storms. So this is kind of a very small ridge. That's a little theta E axis, and that leads up to the storm complex right there. So that would be an area we would be looking at for stronger cells. Although along that axis there is a lot of cell competition going on. Out in Illinois, though, theta E is a little bit lower, so probably not as much moisture. But after looking at that cell near Rockford, they've almost definitely got a very good shear profile going on. When you have very good shear, you really don't need that high CAPE and very rich moisture. You can get rotating storms without that. Okay, here's the hemispheric pattern. This is up at 250 millibars. This is a chart. Yeah, people ask about this every once in a while. This is a chart from Canada. You can see the Environment Canada label there. This is an internal chart they use there. And this is showing a large long wave across the central northern Pacific. Looks like maybe another one in the eastern U.S. And I suspect what we have here is probably ridging with a major trough moving through it. And of course, Europe also active. And let's zoom in on the U.S. and we'll go up just a tiny bit to 200 millibars. This is going to be up at 39,000 feet. And there we can see the polar front jet. At least I think this is the polar... Yeah, that would be pretty far north for the subtropical jet. But it looks like 90 to 100 knots right there through Denver. I don't know, that could be the subtropical jet actually. We're going to have to look at the data for that. This is certainly a segment of the polar front jet right there. And then this is the other corresponding segment from the Great Lakes, Lake Superior down to Kentucky and down to the Carolinas. And then this section right here, this is the subtropical jet. Little 50-knot segment through the Tallahassee and Jacksonville area. Things kind of quiet in Texas, but you can see that troughing right through here. See that troughing axis? North of that we have northwest to northeast flow, and south of that we have westerly flow. So this is a little cold pocket. When you have troughing aloft, that's usually caused by denser air underneath. And if that's in the mid to upper levels, then that's going to cause instability. In this case, we haven't had too much storm activity here in Texas, so I think that trough may have moved off to the east a little bit today and may be affecting us a little bit less. Okay, yeah, this is a chart that I wanted to move to. This is 700 millibars. And remember, this time of year, pretty much from spring into summer, we use this to keep tabs on the cap. So here's the 10 Celsius line. It goes from Wyoming out to almost to Omaha and then southward along I-35. The 12 line, just like that. And then the 14 over Albuquerque in southern Colorado. So what does this tell us? Well, it shows we have westerly flow across the Central Plains. You see the wind right there. 35-knot winds, 40-knot winds out of the west. So that's advecting a lot of this warm mid-level air out into the plains. So we're seeing increased capping in the Central Plains, and that's right over that high theta E area that we were looking at on the other chart. So what's happened is we've had a strong increase in capping during the day today. However, that area of capping has not quite reached Missouri and Illinois yet. So that air is a little bit more uncapped, and it did fire earlier during the afternoon. And then there's the 850 millibar chart, and since this is 12Z, we use this to keep tabs on the low-level jet. So in this case, if I outline the 40-knot contour, it's going to look something like this right here. So there's the low-level jet, and then I'll do 45. So this is basically the flow from the south. So this is advecting some deeper moisture up into the Midwest area where we have those storms going on. And then 925, we can kind of look at the same thing there. This is down at 2,500 feet MSL. Okay, let's head on to something more interesting. We'll take a look at the satellite data. I know those charts we looked at, they do tend to get kind of dry. So there's our storms up in Illinois and Iowa. This was a little bit earlier today, but you can see that they were firing over Des Moines. And there's a leading edge of that cold front right there. It looks like maybe a little bit of a dry line segment in western Kansas right there. Or maybe some sort of outflow boundary in that area. So something going up right there. And then we've got upslope storms over the Denver, Cheyenne area in the Nebraska Panhandle. And then out in West Texas, we've got something going up in that area. So we'll take a look at that. Probably some good easterly flow moving into that region. And elsewhere, you can definitely see the sea breeze working its way inland, and I'll draw that out. There's that sea breeze. Not quite as active as what we had yesterday, so something has happened. Maybe we're a little bit more capped. Maybe there's a little bit more dry air involved today. And in fact, I think we were talking about that yesterday. Big convective cluster offshore overnight. That probably ate away at our moisture supply, and that's the reason that sea breeze did not really get going. Okay, tropical storms. We had Dora out in this region here, just south of Baja California. That's moving off to the west, and it's not even carried on their charts anymore. They do have a little area of 10% forecast south of Acapulco. And then out in the Atlantic, nothing. So we're turning to kind of a quiet weather pattern. And this is a quick look at West Texas. I figured I would throw this in here for something different. This is showing the Davis Mountains of West Texas. And keep in mind that the deeper moisture is kind of in this area, kind of funneling up the Rio Grande Valley. And then the drier air is found out to the west. So the better storms in this case would be right there along that leading edge. So pretty good tower right around the Fort Stockton area right there. You can see that right there. There it goes. Another little cell developing back behind it. And yeah, then there's this other one that went up in that region. So let's take a look and see what's driving those storms in West Texas. Yep, there we go. 60-degree dew points, making it very far west toward the mountains of the Davis Mountains there. You can see that moisture coming right up that river corridor there. And the geography of Texas looks like that. And you can see as you go west, you get into increasingly higher terrain. And here's the Cap Rock. This is probably not a great chart because it's actually very flat here. I think there's probably a different presentation we could use that would really help the Llano Estacado. really stand out in this region. But we see most of the very strong increases in elevation right in this area here in blue. That's the cap rock. That's a very important area for storm formation during the spring and early summer. And then, of course, also this area out in West Texas, the foothills of the Davis Mountains. Okay, we'll keep things moving along here, and I guess we will head into some of the model data. This is the thickness chart analysis, so this is one other key to what's happening. So we use this to get an idea of what the fronts are doing. So we got a cold front off in the Atlantic like that, pretty easy to find. There's a warm front right there, and a little bit of thickness gradient there in Colorado, and that looks like it connects up to the system like that. And you may wonder why you would want to use this chart. Well, it can be difficult using the conventional surface analysis like we have here in mountainous terrain and where we have a lot of mesoscale boundaries. So this is more of a synoptic scale picture, and it can kind of cut through a lot of that. And it also considers kind of a layer from the surface up to 5 kilometers. So this will help you get a quick look at where the fronts are. In this case, from Minnesota down to Colorado and down to California. And the warm front really stands out very well. And there it is there, from about Minneapolis to Chicago. Okay, yeah, we should take a look at a sounding, maybe for Lincoln. We'll plot that up. There's the 12Z sounding for this morning. So what does this tell us? Well, not much capping, a little bit of capping right there. We can see that there's kind of weak mid-level winds. Okay, so that area of 30-35 knot winds has not quite moved out to Illinois yet. That might have happened during the day, but then we also see pretty strong northwest flow aloft. So storm's definitely very well ventilated. And we see a high tropopause, which indicates kind of a tropical air mass. And the moisture we have in place is kind of on the weak side. You can see that moisture profile there closely follows the 8 gram per kilogram line, kind of like that, which translates to upper 40s to low 50s dew points. So the air mass has actually undergone a lot of modification since then. I'm sure it's come up into the 50s. Let's see what it is now. Yeah, there we go. 60s have made it up into Illinois. So the models would actually handle that pretty well. You could modify that. Modify the sounding based on those conditions. So that would be the moisture. The temperature line, what do we got going on? 80. Okay. So the modified temperature line is going to look like this. And then the modified moisture line, I would start with those low 60s and then bring it up kind of like that. And then the mid and upper levels, you would go with whatever the models are forecasting, because that's going to be a lot more accurate than trying to guess at it. And just assuming that there isn't much change, we can go ahead and solve this. So here's our lifted parcel. So that's going to be about 1,000 CAPE. Very small amount of capping, and a reasonably low LCL. And I can see there with 78/62, yeah, that's going to put basis probably in the 3,000 to 4,000 foot range, which is decent for supercell storms. And you can see a little bit of that directional turning already present in the wind flow there. Let's see if we can get an updated sounding from Lincoln. I'm going to move this up to the 29th at 0Z. And we'll try plotting this out. Yep, we've got the latest data. So now you're seeing some of the changes going on in the sounding. So it looks like our guess was pretty reasonable. We've started with around 16 or 17. I had thought maybe it would be kind of like this, but it was actually a little bit more to the left, a little drier in the 5,000 foot range. Our guess at temperature was pretty close. And then it looks like the rest of the sounding kind of remained similar to what we had this morning. So if we lift this, well, actually they've got a parcel lift on the chart already that looks pretty reasonable. Now obviously this doesn't tell the full picture, because obviously there is instability present in the atmosphere. We can definitely see that there on the radar imagery. So chances are what's going on is there's some better moisture that's making it up to these storms, and it's not being sampled well by the radiosonde station, which I guess is down in this area. Yeah, down in this area somewhere, probably right there. So we know that the winds are kind of out of the southwest, so better moisture is probably just west of that radiosonde site. So maybe the moisture profile is looking a little bit more like this. Okay, then the wind. Well, you can see some strong directional turning. The velocities are on the order of 15 to 30 to 35 knots. So you're going to get, when you plot out your hodograph, you're going to get a shape like that right off the bat from surface up to about 8,000 or 9,000 feet. So definitely some circular segments in the lower part of the hodograph right there that stands out pretty well. And just the slightest amount of backing at the surface will really bring that up quite a bit. So we can take a quick look and see if there's any backed flow. Well, not really. Maybe a little bit of backing right here. But this is where mesolows really become important. So if you have some strong upper air lift, very small focused lift working towards the area, you may see an area of pressure falls approaching the area where your storms are, and that could start backing the winds around to like 150 to 140 in this area here. So those are things you have to watch for when you have storms going during a situation like this. Okay, let's see here, moving along. We'll just bring this right up to the model data, I guess. And we'll look at the forecast, mesoscale forecast overnight. Looks like a bit of an MCS moving across Kansas overnight. There's 4 in the morning. And you can see that kind of moves to the Kansas City area during the morning. And then what we have going on in Illinois, looks like that also moves southeastward as an MCS, kind of in that direction towards Indiana. So that'll probably be in the Indiana area, maybe in Michigan later this evening. And since we're about 49 minutes in, that should bring us up to the forecast for the next 5 to 10 days. Yeah, let's check it out on this chart for a change. And before I go too much further, let me take a look at the chat here. And I'm probably not going to be able to read all of this because there's a lot of text here, but Arakiel calculated the square root there, 197. So yeah, you basically multiply 197 times 200 to get the feet of one length of that fire area. I'm probably confusing you all. Let me just calculate this real quick. Okay, 200 times 197. Divide that by 5280. Okay, so you're looking at area on that fire in Arizona 7 miles to a side. So that gives you some idea. 300,000 acres, whatever it was, doesn't really tell me as much as like how large the area is in square miles. So doing that calculation kind of makes it a little easier to visualize what happened. Okay. Strong couplet from Rick McAllister on the Rockford storm, 120 knots gate to gate. Mr. Manlet ditch in the backyard flooding under a flash flood warning till 2:30. Brett Dean seeing flanking line convection. Eddie W. joining us, and Eddie W. says he was out, didn't see anything good. Last second chase, more focused on the road, was pretty violent with horizontal vortices, at least EF2 damage. So it looks like Eddie W. there did catch some footage. And he's got a new dash cam and new tripod, so that's always a treat to get. Ryan says all the tropics are quiet at this time. Brett Dean says don't forget to hit the like button and comment and subscribe too. And I do reply to the comments. It sometimes takes me a few days to get to them, but I have been keeping up on that. Ron Chalfant says, finally a nice day in the San Bernardino Mountains, 80 degrees today. And they were 120 down in the valleys last week. He didn't know about the fire in Riverside. Ray Woody joining. Justin Pulliam mentioning the sea breeze there. Ron Chalfant hoping for some monsoonal moisture around the 7th of July. And a little discussion there about Southern California. Okay, so we know where the fronts are. Okay, so it looks like there's something there, and we saw this earlier on the charts from Minnesota down to Colorado. And, oh, I'm sorry, it's a little bit of a coincidence. Yeah, we were looking at a chart about a week in the future, but yeah, there's a front in the same area. There's the warm front. So moving that forward into tomorrow. Trying to get the map to cooperate here. Give me just a second here. Okay, there we go. So overnight, there's that MCS there in Illinois. Looks like that moves to the east and kind of dissipates by dawn. There's that MCS over Kansas City. And then by the time we do the webcast tomorrow, let's see, it looks like we got a little bit of frontogenesis maybe in Missouri, about right there. Cold front moving through western Kansas into southeastern Colorado. And then the tail end of the front kind of like that right there. And probably a dry line set up in West Texas, something like that. This is showing that we've got an MCS in northern Missouri in the Kansas City area. So we'll be looking at some storms there tomorrow night. And then moving forward into Friday, that front sags southward into Oklahoma. You can see the moisture feed is coming up from this area, moving northward. And that's feeding basically where this collides with the frontal boundary is where we are looking at convective development. So probably an MCS from St. Louis all the way back to Oklahoma City looks definitely reasonable. And then for Saturday, looks like that front has sagged down into the Red River Valley. We're definitely looking at some mesoscale boundaries that the GFS may not be picking up on. So there's going to be a lot of an uncertainty how far north or south this boundary will be by the weekend. So we could see that south of DFW. We could see it up in Oklahoma City. But in any case, it does look like we've got some rain somewhere between I-20 and I-40 there. And there's the feed of moisture perfectly positioned to feed the I-35 area. Going into Sunday, moisture continues to stream north. The boundary lifts northward. There's that front right there. And we're back to the thermal low in southwestern Kansas. So things will quiet down a bit for Sunday. For Monday, the flow picks up a little bit from the south. Looks like we have an approaching shortwave. Warm front in the Kansas City area setting up, and that'll help support this little MCS that the model's picking up on. And then for the 4th, we're going to see that MCS probably move eastward overnight into Illinois. And then by the evening, yeah, it's going to be pretty widespread there through Illinois. And then looks like another little segment down in Kansas, but pretty quiet here in Texas. Then for the 5th, moisture supply continues to move northward, but I guess we're going to be under a little bit of high pressure aloft here in Texas, keeping things shut down. For the 6th, another front coming southward out of Canada. There it is right there. A little bit of thermal low there in the Texas Panhandle. Then for Friday the 7th, looks pretty quiet there. Model going for scattered showers across the Ohio Valley. And then looks like something is going on in Texas around the 7th or 8th. Yeah, I can see it there. I don't know if you can also see this. Looks like a cold front pushing southward. See, there's a little bit of a baroclinic low right there in northeastern Texas. That kind of appeared out of nowhere, and a lot of showers along that system. So going back a little bit, yeah, I guess we had a little bit of frontogenesis on that tail end part of that front. But considering all the boundaries that we're going to have over the next 7 days, there's a lot of uncertainty how this is going to actually resolve by the time we get to next week. So this is an example where if you were in Texas, you would keep low rain chances going, 20 to 30% chance every day, that kind of thing. And then things look to quiet down a little bit in Texas after that. And then we'll just take a quick look at the moisture and see what that does over the next 10 days. 70s going all the way up to the Midwest right there where we have those storms. Another surge of moisture, 70s coming up to tomorrow. And then you can see that front pushing southward through Kansas right there. 70s coming up and hitting that boundary. And that means precip in Kansas and Oklahoma over the next few days. And there comes that front southward before it retreats northward over the weekend. And there we've got a little bit of upslope there. Boundary definitely along a line like that by Sunday morning. And then you see it moving northward all the way up to Nebraska by evening. And then the moisture just kind of builds back in, 70s dew points across East Texas and up in Oklahoma. A couple of low pressure areas, and again, that's going to depend a lot on where the mesoscale boundaries end up. There's another little push of cold air right there. Northerly flow ahead of that. This is on Friday the 7th. And that makes it to about the Red River. And then we're going to expect to see it move back northward after that. Those boundaries, the GFS is going for maybe a position along maybe Houston to Austin. So yeah, maybe a little bit of rain around the 8th or 9th, kind of supporting that idea of low 20s to 30% chances of rain. So that's kind of how we go about building the forecast in the middle of summer. And we'll take one last look at the chat, and then we'll look at the storms. New tornado warning in northwest Missouri there from Mr. Manlet. And Rick McAllister there talking about a 1003 surface low near Southern California on the 7th. Okay. Northwest Missouri, okay. So new tornado warning right there in, I don't know what town that would be, but along the Iowa-Illinois state line. And there's that new tornado warning all the way out in the Kansas City area. So I would have to bring up that radar. So let's do that real quick. Wow, the Kansas City radar really far south. I wonder why they did that. That radar really needs to be maybe out in this area here. There's just not very good coverage in northern Missouri. Okay, so there's a tornado warning right there. This is going to be for Gentry County and Nottoway County. Severe thunderstorm near Stanberry, producing radar indicated tornado. And we'll take a quick look at that cell right there. That's a little ways from the radar. But the velocity, yeah, definitely showing some very closely spaced shear. Right in that area. It's about 32 out and about 44 in, so about 80, probably about 80 knots of gate-to-gate shear there. Also showing the strong convergence. So looking strictly to and from the radar, you can see convergence with inbounds right here and outbounds right there. So that is a good sign that this rotation will continue to evolve, and the severe weather's probably not quite over for that storm. So there's a dot where that tight circulation is, and that's pretty much right at the tip of that hook echo, just southeast of Stanberry there. And you can see what looks like a little bit of a RFD maybe right through that area here. And I suspect that the older meso is probably back in this area, and then the forward flank downdraft boundary probably right in that area there. So the updraft base right there, and this is where the storm chasers would be accumulating. Okay, so just taking one last look at that. Okay, so yeah, storms going on there in northern Missouri and northern Illinois and in the Quad Cities area. And I think that's probably about all I got for this evening, so hopefully you all enjoyed that. We ran a little bit over again, 63-minute weathercast, but hopefully that gives you a good refresher on how to forecast weather this time of year and look at the radar and analyze those surface charts. All right, so we hope to see you on tomorrow night, and until then, take care.